Hi, BMIS 270, and this is, um, actually part two. And this particular section will talk about feasibility, cost, direct and indirect costs, tangible and non-tangible kinds of costs as well. So initially, we'll start out with feasibility. And we have four different kinds of feasibility: economic, operational, scheduling, and technical feasibility. And where all of those comes together, that means that a project is probably actually doable. Now, some of the areas, though, with operational and cultural feasibility. So the questions that you would ask, probably the most important question initially: does management support the project? Because if you don't have management buy-in, they are not going to follow through with any particular project. So also, are the users not happy with the current business practices? Will a new system reduce the time considerably that people spend doing business practices, doing business processes? If yes, then they'll welcome a new change to the system, a new change to that system. Now, also very important, have users been involved in the planning and development of the project? So when you get users involved early on, the likelihood of user acceptance is greater. So from the very start, if you have a committee that puts together this particular project, starts the investigation, if you have some folks who are typically users, I would say, rather than IT people, their perspectives are different, and and therefore would benefit the project in a more holistic sort of way. And also down the road, when this project is actually implemented, there's greater buy-in. Now, will this proposed system really benefit the organization? Computer phobia is an issue. Depends upon if you have a younger, and then I'm speaking generally, okay, if you have a younger 20, 30, 40-ish age group of demographic for company users, that acceptance toward technology will probably be greater than if you have primarily a 50 or 60-year-old particular set of employees. So I'm just using this as a rough example. That is not necessarily so whatsoever, but those who might be in the first category might be more accepting of new, less phobic to computer information systems submitting data online than those in an older particular demographic. So computer phobia is an issue, and it can be an issue. So also, perceived loss of control. Now, this oftentimes comes from the IT department, where they had certain control over certain data and applications, and you have to be with new systems and changing business practices. Not just IT, but business people sometimes have to be willing to believe that they're losing control of a particular system. And in doing so, may be difficult for them to do. There may be, along with that, is a shift in power, and then also fear of job change or employment loss. Okay, and then because with new systems, say you're a COBOL programmer, which is ancient, and if we go to something newer, well, am I still going to have a job since I'm a COBOL programmer? I would hope, and ethically, that those same programming logic, knowledge, and skills are still important. It's just retraining that needs to happen. And so I would hope that retraining would happen in this case. And then reversal of established work procedures. So sometimes those work procedures may change. These are all examples and questions regarding operational or cultural feasibility. So if these things can happen. Have users been involved? Management supports the project. You can have successful operational feasibility. It can be successful. Now, the next piece, specifically technical feasibility, is something we as CT majors will appreciate more. So with technical feasibility, whether the required technology is available or not, Okay, is it available? Whether the required resources are available? Now, and that's really important to make the project work and to make it be successful within the given amount of time. The manpower, or people power, I should say. Programmers and testers and debuggers. Do we have the people to do that? Can we get the people to do that? Software and hardware feasibility and expenses. Our server system, can it be scalable for new business? Because a new project, and we'll use this example, it's a new project, a new website where we hope to get a lot more business. Can that hardware and software that we currently have scale up to the new growth in numbers, in consumer numbers? Now, do we have the in-house expertise to develop this project? A lot of state government will go ahead and develop projects in-house typically, not as a general rule, not always, but as a general rule. And oftentimes they have different departments and different groups of people that they can call on to actually pull together the expertise to do a particular project. The next question would be, how does an outside vendor need to be involved? So with a lot of smaller business, a lot of different businesses, it's more affordable to actually go in and to outsource the project, essentially, to get people from outside to do it. Those people from outside are experts. They may cost you a lot of money, but you don't have to pay that expert year in and year out when it's in your business. Okay, so outside vendors are often a great way to go, especially for smaller businesses. Now, solutions include training or hiring more experienced employees, hiring consultants, and changing the scope and approach of the project approach. So when we're thinking about technical feasibility, is it feasible? Again, do we have that? Is that current? I should say it this way: is that required technology available? Do we have the resources available? Do we have the people power? Or can we get the people power? Do we build this in-house? Can we do that? If we can't do that, and we're not willing to pay for an outside vendor or outside consultants, then this project is technically not feasible. Okay, so that's some of the questions that revolve around technical feasibility. Scheduling feasibility. Now, how reasonable how reasonable the project timetable is? Okay, overall, think about again that interchange down there on Custer. With their scheduling feasibility, they only have, and of course you can work it over a couple of years. You can do a number of different things, but they don't have winter months. Probably typically from November to April, they probably don't have that time. They only have May through probably October to actually work on the project. Can they get that project done in that amount of time? That's a scheduling feasibility issue. Now, given our technical expertise, are the project deadlines achievable? That's with an IT sort of project. Okay, if we have to develop with this in-house expertise, if we don't have all of the expertise necessary, we're going to have to send somebody to some professional development, some trainings to get that expertise, and then they're going to be at a lower level of expertise, and it'll take them some time to get up to speed. So, with that said, given our technical expertise, are the project deadlines achievable? It's a good question. Estimates needed without complete information. So, oftentimes that's the case with scheduling feasibility. You're giving it a best guess. Now, we won't really worry so much about scheduling feasibility, although it's really important. Economic feasibility is what this section doesn't completely talk about, but kind of focuses on. What's the cost of this system? With cost-benefit analysis, what are we doing? We're determining if the expected benefits equal or exceed the expected costs. Otherwise, why do a project if you're not going to make some money at it? Estimate project development costs. You have to figure out how much the project's going to cost you. Estimate operational costs after the project. What's it going to cost to run this particular system? People time, power, hardware, software, licensing costs, all those pieces. Estimate financial benefits based on annual savings and increased revenues. Figure out tangible and intangible benefits, And what we're going to take a look at is net present value, total cost of ownership, return on investment, and then cost-benefit analysis. Now, let's kind of define direct or indirect costs and benefits. A direct benefit is attributable to a given project. So if a proposed system can handle 25% more transaction than the present system, okay, if the proposed system can handle 25% more transactions than the present system, then it's a direct benefit. Okay, direct costs associated with the development of or maintenance of a project or of an information system. Indirect benefits, well, greater efficiency and ease of completing transactions improves second-time buyers by 10%. Now, that's not scaling up initially. That is people liking the site and coming back. So that's those second-time buyers is an indirect benefit of that initial project in this case. There's other great examples of indirect benefits as well. Next is indirect costs. Those are not directly associated with the system. Now, and those costs are like insurance, maintenance costs, heat costs. Air conditioning can be a huge cost. So some examples of, well, first of all, what direct and indirect costs and benefits are, and some examples of those. Now we have tangible and intangible costs and benefits. Tangible costs and benefits can be identified and measured. So, they're typically figured in dollar values, but performance, being able to complete 50% more transactions in a given amount of time, that is a performance gain, and so that's a tangible benefit. Now, intangible costs and benefits cannot be identified and measured. And true, some of these may be measured in some way, but typically we would consider some areas as intangible. So some examples: tangible costs, hardware costs, salaries for professionals, software costs. Tangible benefits, improved response time, that's something we can measure. Producing error-free output, again, something we can measure. Now, intangible costs, employee dissatisfaction. How could you actually measure this in some way? Well, you could give surveys to employees, and then establish a benchmark, improve the system, and then give that same survey later on, so that you can see what the improvement would be. So, is it really an intangible cost? Typically, satisfaction, whether it be customer or employee, is typically considered intangible. It's hard to quantify what kind of impact that has on the bottom line of your system. Just because they're dissatisfied, how much money is it really costing you? You can determine the amount of dissatisfaction, but how much is it costing you? And that's why it's intangible. Intangible benefits, more customer satisfaction, improved company status. Once again, it's the same sort of thing. So your customers are happier, and you can tell this by surveys, but can you tell whether the improved profits are simply from a better working system, an improved economy, or because your customers are happier? How can you tell that? So again, that's why that would be an intangible benefit. Let's see. Finally, cost and benefit categories. So these development costs are hardware, personnel, facility, supply. Operating costs tend to be hardware, software, personnel, wages. And make sure that we identify or understand the difference between development costs. This might be a consultant. This personnel wages might be a consultant. The personnel wages and operating costs are from the day-to-day running of the system. The facility, daily maintenance, and supplies. And here is kind of a breakdown in the PowerPoint of these particular costs and what they are. Now, to look at this, if we look at a cost-benefit analysis, this is what a typical system will look like, the payback on a typical system. These are just costs. So initially, this development time, there's a lot of costs associated with it. Okay, and so you have a lot of upfront costs. Now, at this point in time, your costs tend to be lower, and this is where your profits are higher. Okay, that's why this is considered the economically useful life. Your profits are higher, they are greater than your costs are, the system is running fairly efficiently, and at a certain point in time, that system is going to become less efficient. Now, maybe due to the number of customers that you have, maybe there's been an increase in customers, maybe it's been an improvement in technology which makes your system less efficient. But there will be a point when that cost of useful life starts to end. And then at this point, at the very end, it may still be profitable, it may be breaking even, but at this point, you're starting to think about redeveloping a new system. So reinvestigating, reanalyzing, what are the problems? Well, technology is too old that we're using, so we have to go to something else. And then this is the point where you start all over again to develop a new system. Okay, so with that, we've talked about feasibility, operational, cultural feasibility, technical, scheduling, and economic feasibility, direct or indirect costs and benefits, tangible and intangible costs and benefits, and then finally looked at some categories, and then looked at what a typical costs of a system and the payback analysis looks like for a typical system over any given time. Okay, thank you.